Good afternoon, everyone. Thanks for taking time out of your busy day to join us for the lithium-ion battery management webinar and guidance document launch. So we'll get stuck in, but just a little bit of background on this. Why do we go down this path? Well, we were getting a lot of inquiries about how do we manage EV charging, and what about scooters and bikes, and how do we deal with this? So given the volume of inquiry, we thought it appropriate to put together a guidance document, and I contacted TEFMA, and they saw the merit in collaborating on this, because a lot of these inquiries essentially came from the facility management teams, and it was an issue that needed to be addressed. So what we did was we formed a working party. There was 15 of us on that working party from a range of different institutions. And the team was made up of facility managers, WHS professionals, and project management and sustainability experts, because this issue actually is wider than just facilities management. So we thought it important to get the views of all, so that we could have the best possible document that covered the full range of issues. So we sat down. The first meeting, we decided, well, we really need to understand what our scope is and what our objective is. And we decided that, it was necessary to provide clear, concise, and pragmatic guidance regarding the management of emerging risks associated with lithium-ion batteries. Also, to consider minimum requirements for the location and operation of charging points. So where do we put them? How do we install them? What do they look like? And also to help all stakeholders understand the risks, and ultimately to minimise property damage should an event occur. And in a global sense, it was really to minimise risk to campus communities generally. So what will you see in the document? So the headlines in the document are the context and risk landscape. So what we've tried to do is to put it into a risk management framework, so to speak. So the first thing, we set the context and we understand the risk landscape. And here we look at some of the growth figures, the incident data, and what is becoming a bigger and bigger issue for the broader insurance industry generally. The next one is risk identification. So what actually is a lithium-ion battery? How is it made up? What does it look like? And what are the risks that their operation presents? Risk identification is good, but you've got to have risk control and mitigation strategies. And, we focused a fair bit on this in the working party meeting. So how do we really deal with this issue? So you'll see some control strategies and minimum protection recommendations. But, it's just not about where you put your EV chargers or your e-bike and e-scooter charging locations. It's much broader than that. It's about tools. And we'll get to that issue in a minute. So we thought it's also important to address the operational considerations. And what we've done is structured a 6-element framework to cover that off, including education, operation management, monitoring of batteries, contract management, because, there's constantly contractors on campus, also tenders, procurement, and ultimately at the end of the battery life cycle, safe disposal. So we've taken a cradle to grave approach with this guidance document. So what's in it for you? We wanted to make this document something that you could access, that you could reference, and that you could take reproducible material from for your own use. So what's it got in it? It's got useful facts and figures. Ultimately, they'll become outdated, as statistics and stuff grow, but we intend that this be reviewed every 18 months or so. There's a series of quick reference tables, risk assessment tables, risk control and mitigation tables, all of which you can copy and paste into your own documents. There are design consideration checklists, procurement risk assessments, so even a little bit on greenhouse gas emission considerations. And again, so that this information is accessible, you can copy and paste tender questions and contract clauses. And not only that, there's heaps of other links and references that you may find useful. So, setting the context and looking at the risk landscape. When you look around your house, you will probably find at least 30 items which contain either removable or embedded lithium-ion batteries. You can read the list there yourself, but they're in devices that we use on a daily basis. It is now the leading portable energy storage technology globally, and it's just growing. So there's increasing demand as the higher education sector ultimately advances its transition toward net zero emissions. What are some of the things you've got to deal with on campus? Well, transport within and beyond campuses, be that bikes, electric vehicles, scooters, however that happens. We're seeing increasing numbers of fleet vehicles, which are now EVs. Maintenance and trade operations, that's a biggie. Pretty much most of the trades these days use tools with lithium-ion batteries in them. That includes grounds maintenance, your mowers, your whippersnippers, your blower vacs, as well as your cleaning equipment. So the message is this power source, these batteries, they're here to stay and they need to be managed. What's the broader insurance industry perspective? What are the markets telling us? They're telling us it's an increasingly costly and complex risk. And although it's essential to the way we work these days, lithium-ion batteries present serious insurance challenges. What are the underwriters telling us? They need confidence around the management of thermal runaway risk. That's the big risk, thermal runaway, and we'll get to that shortly. But the thermal runaway, the fires ultimately lead to property damage. They can present safety risks. And some of you may have seen the transport of EVs and, large quantities of batteries on ships which catch fire. That's a big one for the insurance industry generally. So what's the emphasis from their perspective? They're telling us clear and enforceable strategies for safe charging and storage, ongoing maintenance and monitoring of your battery stock, your tools, etc. Have a framework where there's documented accountability for procurement, handling and disposal, because the disposal risks have to be insured too. And this is what and we'll get to some of these stories a little bit later on. But, it's a life cycle thing. Procurement, use, management, monitoring, and ultimately disposal. And of course, they want to see an alignment with current safety regulations and standards. So ultimately, you can run from this, but you can't hide. So with growing demand comes greater potential for incidents. The adoption of electric vehicles continues to accelerate globally, and we have some of those stats in the document just to provide context for you. Personal mobility devices, including e-bikes and e-scooters and other micro-mobility options, are experiencing rapid growth in Australia. I've even got two in the garage at home. Lithium-ion battery incident statistics are revealing a sharp and concerning upward trend in fire events. And that's even with what we perceive to be underreporting of incidents. And this is what the fire is and other emergency response agencies are telling us. Look, this issue is being underreported. And what that means is it becomes a barrier to understanding the true scale and nature of lithium-ion battery fire risks. So if I was going to give you a call to action, I'd say now's the time for the sector to act, not only to prevent costly property damage, but most importantly, to future-proof infrastructure and ensure a well-managed improving risk profile. So onto the risk identification. That's enough from me for the time being, and please give him a warm round of applause and welcome him to the stage, Greg Burton.
Well, thank you, Simon. I'll be talking just a bit about what the lithium-ion batteries typically look like and the risks presented. So a little bit of electrochemistry, which always does get a big round of applause, I'm sure, and the mechanism for breakdown. You can see with this first slide, we've got various types. When you often look at, say, a lithium-ion battery on a bike or whatever, you might see the outside housing, but the actual battery cells inside might be various different types of shells. The cylindrical, it's a bit like normal cylindrical batteries you may see for a lot of traditional appliances, but they're also quite common and for lithium-ion batteries. The advantages they have is simplicity for manufacturing, and also they have a certain amount of rigidity, which is good for structural integrity. So they're more common than you actually think for lithium-ion batteries. The second one, I'm just going to the right-hand side, is prismatic, or sometimes you call them rectangular. Obviously, they're more of a prismatic shape. The advantage they have is that there's less dead space and having to use a whole lot of cylindrical batteries. They have good energy density per volume. They are higher cost, and there is more of a chance of deformation and damage. Going to the bottom row, button. This is really more of a niche type of battery in the case of lithium-ion. Could be there for devices such as smartphones. Pouch. Also less dead space, and it's got flexible sizing compared to cylindrical. More subject though to mechanical stress, and the swelling risk may require more thermal management or complex thermal management. Often find them in devices such as laptops and mobiles. We can go to the next slide. So now for a bit of electrochemistry. Basically, for layperson, it's got on the either side there collectors. These are basically where you've got electrodes. During the discharge, you have, as in this drawing, you'd have ions that are going to be liberated from the anode and then transfer across to the cathode. When it's liberated at the anode, you're going to release electrons, which then connect around in a circuit to the cathode, where the ions then recombine with electrons, I should say, to complete the circuit. The opposite, when you're then charging, you've got the ions moving in the opposite direction. And this is the ions, I should say, too, are moving through what we call electrolyte. In the case of lithium-ion batteries, these are a hydrocarbon material, therefore they're combustible liquid in there. And there's a barrier between the two. I said there's obviously a movement of electrons. You don't want the two collectors or electrodes to be in contact with each other, otherwise you have a short. So there's a barrier between there which is porous to allow the ions to move through there. We talk about lithium metal oxide, and you can see the drawing there. They've got hexagons there. It basically, you'd have a compound along there, which is a lithium-based compound. So there's various types that are used: lithium manganese oxide, lithium iron phosphate, lithium cobalt oxides. These are some of the names you might hear. The different material compounds used give different characteristics to the batteries. Just under their normal, although we, during the charging at the cathode, you're going to, although there is a change chemically in the surface, oxygen, which is part of that compound I mentioned before, is there, but it does not generate oxygen unless you have overcharging, in which case oxygen gas can form, and this hazard we'll be talking about a little bit later on. We go to the next slide. So batteries are often made up of a lot of individual cells. Basically, it's a system with the cells either in series to give greater voltage, and then in parallel for more current, to build modules, packs, and integrated battery system. As you can see on the right-hand side there are for very large systems. You would have also battery management system and cooling systems, which are very important parts of the system. We'll go to the next slide, if we may. What can go wrong, or why should it go wrong? You'll hear us talk quite a bit about quality. So obviously, if you have poor manufacturing or poor materials involved, there's more likely to be, say, uneven charging or shorts across areas, or degradation of the materials over time. So certainly quality is quite important. That's from manufacturing all the materials of construction, but of course you can also damage batteries from impact, whether that be in transit or just everyday use. We would say that particularly things like e-bikes and e-scooters are probably more likely to get damage during their normal life. Also exposures. Most batteries, the manufacturers will have temperature ranges that they normally should be used in. If you have very large systems too, although battery energy storage systems, BESS units are not part of the scope. If you go into those, they often have a lot of air handling to keep the systems cool. If you have it going too hot, then that can lead to greater degradation. The other one too, which I think is coming up quite a bit, of course, is overcharging. Normally, at a certain point you would charge, then you would take the charge off, then you would be ready for discharge at normal use. But if you're overcharging, you may actually start to have a breakdown of the compounds used in there, and it could lead to either breakdown leading to oxygen, either from the compound on the cathode, or even the oxygen which is present as in those hydrocarbon electrolytes. And we'll just go on to the, sorry, just one last thing. Obviously, I said before about the oxygen, this is quite an important differentiator between a lot of other fires. If you say had a example hydrocarbon fire, you have to have the fuel, the hydrocarbon, coming in contact with the surrounding air. In the case of the lithium-ion batteries, though, there are oxygen present as compounds. It's not normally in gaseous form unless there's some type of breakdown. But if you do have that thermal runaway, if you do have a breakdown in the materials, then you're going to start to feed oxygen in at the source of the fire. Go on to the next one, if we may.
Well, just sit back and enjoy this. And hopefully none of you have had these experiences.
Looks like that one's in Japan. Yeah, this one's an interesting one.
Smoking is a health hazard, but it's also a fire hazard, apparently.
Apparently.
Ouch. The dog's onto something here. Imagine if that was in landfill, it would be extraordinarily difficult to put out. It's hard enough in a contained location like this. This is what we call a large-scale fire test.
Yeah. So this one, they've deliberately destroyed it or initiated a breakdown, runaway. See there in that last shot, there was quite a lot of those cylindrical batteries, and that was an EV. EVs can use quite a varied amounts of various types of batteries for different applications. Okay, back to myself. So we talk about thermal runaway. You're going to have basically heating and breakdown of barriers and the chemicals involved. I talked before about oxygen forming. The oxygen may be present, well, not maybe, it will be present for the lithium metal oxide at the cathode, but it's also in the form of hydrocarbon compounds which have carbonate. For those of chemistry minded, we know that there's oxygen and carbonate. So there is gas that can form there. Also too, as the heating occurs, once again, you're going to be the hydrocarbon, and particularly once you have overpressure and it's being released to the outside area, the electrolyte once again can form hydrocarbon vapors as it's released, which is going to burn. This normally, it'll occur with one cell. You'll get overpressure, it'll rupture, and then the heat from one unit will then go expose the adjacent ones, and the fire will spread that way. Okay, on to next slide. I think that's now to
I think everyone's just completed lithium-ion battery chemistry 101, so well done, everyone. And I'll hand you over to Glenn Mowbray. Take it away, Glenn.
Thanks, Simon and Greg. Today we've explored the broader risk landscape, I guess, and discussed how lithium-ion battery incidents have serious consequences. What I want to do now is shift the focus on how these risks can be practically identified, prioritised and managed using the risk and control tools within the new guidance material. We've seen and understand that the LIB risks are not uniform. They vary significantly depending on how and where the batteries are stored, charged or used. So that's why we consulted broadly to develop a series of structured risk registers, each designed to help your institution and our members to assess and manage these hazards in a consistent and actionable way. Each register includes a clear description of the failure mode or hazard, the potential consequences if it occurs, both to people and to property, and the contributing causes or conditions that increase risk. They provide a clear framework for identifying where risks are elevated and how to prioritize your actions. And we recommend you adapt the shared risk content to your specific sites to create risk-informed strategies aligned to your physical assets, operations, and infrastructure. If we move on, we note that lithium-ion batteries are relatively rare at the moment, although potentially underreported. They still, however, cause disproportionately severe outcomes, from major or structure damage and toxic smoke exposures to lengthy cleanup and significant business disruption. These are not just equipment failures. They're events that can take entire buildings offline and halt operations for weeks, if not longer. And that's why it's critical to go beyond basic compliance. And you do this by starting out through undertaking business impact assessments, preparing robust continuity plans, and then scenario testing how your institutions would actually respond to a major battery-related fire. At the same time, it's important to recognize these risks are highly environment specific. A charging station in a new open-air facility carries a very different risk profile than one retrofitted into an older basement, office corridor, research area, or near a fire escape. Many legacy buildings and spaces simply weren't designed for this infrastructure, and they lack the necessary protections, whether it's fire separation, ventilation, or emergency access. And when those elements are missing, even a smaller incident can escalate quickly. Next, we'll move on to control measures and mitigation strategies that support safer, more resilient integration of battery-powered technology across your facilities. The regulatory environment for lithium-ion batteries is complex and it's evolving. While there's no single national law focused solely on LIB safety, a combination of work health and safety laws, electrical safety regs, dangerous goods codes, and building standards all apply, depending on how and where these batteries are stored, used, or charged. As awareness of lithium-ion battery risks grow, we expect to see more targeted, consistent, and standardized regulations across jurisdictions. To help organisations and institutions navigate this evolving landscape, our guidance material includes detailed risk registers, including a wide range of controls, covering administrative policies, engineering solutions, behavioural practices, and emergency response and recovery measures. Among these, we'd like to highlight that engineering controls are the preferred approach. Unlike administrative or behavioural measures, engineering controls function independently of human action or circumstance. They provide a more reliable, consistent, and durable layer of protection. They should be embedded within technical design standards, which is an administrative control, and then implemented consistently through projects. In the context of lithium-ion battery risks, engineering control examples might include things like physical fire barriers, ventilation systems, temperature monitoring, automatic shutdowns, and specially designed charging infrastructure. And these features will help contain fires, prevent thermal runaway, and ensure safer charging, storage, and disposal practices, significantly reducing the likelihood and impact of battery-related incidents. You can move forward, Simon, please. As electric vehicles and chargers become increasingly common across Australia, we've seen a rapid transformation in both new and existing built environments. Whilst this does support our shift to decarbonisation and net zero, it also introduces new risks, especially around fire safety, electrical load, and emergency response. The key message here, again, is that not all buildings are equally equipped to handle EV infrastructure. New builds can manage these risks from the design stage by optimizing layouts, ensuring sufficient ventilation, and integrating both passive and active fire protection, smart energy systems, and emergency access. The bigger challenge, as you're aware, lies in retrofitting your existing building stock, especially older car parks not originally designed for EVs. These sites often lack adequate fire separation, ventilation, or electrical capacity, and we've seen charger placements blocking exits and emergency access routes, which is a significant concern from a life safety and claims exposure perspective. Globally, we're seeing government and policy responses. Some countries are banning EV chargers in basements altogether. In Australia, both strata and healthcare sectors are starting to restrict or heavily manage EV charge installation within enclosed spaces. So our guidance therefore responds to this emerging risk. It provides you with checklists and practical tools covering everything from site selection and fire protection to load management and emergency planning for both outdoor and enclosed settings. And we even cover both personal mobility devices and the utility vehicles that Simon touched on earlier. Ultimately, we encourage a risk-based approach, proactive design in new developments, and layered mitigations within legacy buildings to ensure these technologies can be adopted safely, responsibly, and with minimal impact to protection of life safety. My final slide here shows an example of one of the checklists that's included in the guidance, highlighting practical and risk-based considerations that align with global standards and are broadly supported by emergency response agencies. The tools we provide include the tools included throughout the document are designed to help you with high-level risk awareness and turning those into concrete actions. So whether you're planning new infrastructure, retrofitting older spaces, or managing mobile battery-powered devices across your campus operations. But as always, the real value of the guidance lies in how it's going to be applied on the ground. We encourage you to draw from the checklist, risk registers, control measures, and other insights, and adapt them to your operational reality. Use them to support safer design, smarter planning, and stronger day-to-day risk management. So whether you're responding to increasing LRB demand, navigating the regulatory change, or improving your business continuity, this resource and our team here at Unimutual are here to help. And ultimately, we hope this guidance empowers you to make a more confident and risk-informed approach to managing lithium-ion battery technologies across your facilities. Thanks, Chief.
All right. Thanks very much, Glenn. And this is an example of how we've designed this checklist. Now, if I can copy and paste that checklist into a PowerPoint presentation, anyone can do it, right? So trust me, we tried to make this as informative and easy to use as possible. Right. Moving on to the operational considerations. So what do I mean? I mean, if we want to get this spread throughout our organizations, if we want to inform all our stakeholders of the risk presented, the mitigation opportunities, and so on and so forth, I think we need a deliberate and an integrated operational framework. As I was saying earlier, there's 6 elements to this framework, and the first one is education and training. Right, so people need to understand what this is all about and why it's important. So how do we do that? I mean, we're not going to run necessarily standalone lithium-ion battery training sessions, but we can integrate that into our WHS frameworks, for example, into our incident response and emergency preparedness protocols and procedures, which all have an education and training element to them. Signage and user awareness, right? Nothing more impactful than a sign above a charging point, right? Just to keep it in people's minds. I mean, ultimately you get wallpaper blindness to that sort of thing, but you've got to have it there, right? And because these devices are omnipotent and ubiquitous in their distribution, everybody's using them in some way, shape, or form across the institution. And therefore, role-specific training is probably pretty important. I mean, you'd be surprised how many lithium-ion battery-operated pieces of equipment there potentially are in a lab, for example. So forget about the workshops, think about the lab. Your AV equipment, probably in most rooms in a university, right, will have some form of lithium-ion battery integrated into it. So this integrated training approach both equips higher education institutions not only to prevent LIB incidents, but also to respond appropriately should they occur. The next one's tools and equipment. I'll just run through a few things here. You can see the vacuum, the stick vacs. I got a stick vac. Used to live under the stairwell in the house until my dearly beloved decided to stack it full of combustible material, and I had a conniption and put it outside. But drills, grinders, blower vacs, whippersnippers, etc., etc. The list goes on, right? As I was saying earlier, you've probably got about 30 of these devices in your own home, maybe more. So the thing with these pieces of equipment, as was mentioned earlier, is they're more exposed to the potential for battery damage. You know, tools, drills, they get dropped. You know, and the first time you drop it may not cause the damage, but you know, after repeated abuse, these things, this is what happens to them. They suffer thermal runaway. Best advice here is purchase from reputable manufacturers and suppliers and use the charges they give you, right? And ensure those charges bear the regulatory compliance mark, which is basically a triangle with a tick inside. And you'll see all that sort of stuff in the document. The other thing I'm going to say here is you will increasingly find dedicated charging cabinets, you know, small up to big, which, you know, are basically modified shipping containers. Consider charging areas like this, because what that does is it contains the initial fire and gives you a chance. The third element's operation management and monitoring. So what do we mean by that? Well, manage the way you operate these things, implement strict charging protocols, keep an eye on your equipment and check it and maintain it. Again, use quality stuff, ensure proper storage, right? As Greg was mentioning, you know, there is a temperature range. They don't like extremes of temperature. I've mentioned the charging safety cabinets. Surveillance is always a good thing, and that can include smoke detection, heat detection. It can also include CCTV, right? So if you don't have smoke and heat detection, but you have CCTV, at least that gets put back to the central security control center where somebody, you know, has a chance of seeing, oh my God, there's a fire. These batteries are coming in more and more often with battery management systems, so that's always a good thing to look for. And just be careful when you're moving tools, batteries, etc. around, and how you transport them. We also covered off procurement considerations. Now, we've all got procurement policies, right? And, you know, what are the core principles? Value for money, ethical sourcing, modern slavery, sustainability. What we've done here is we've recognised that sometimes not all batteries are equal. They come from different countries. Their lithium might be mined in different countries. I mean, we got some of the biggest lithium mines in the world here in Australia, but that doesn't mean to say that your battery will have Australian lithium in it, right? So the procurement due diligence section of the document's helpful in as much as it goes through the issue of supply chain traceability. There are risk assessments in there for you to copy and paste and use as you wish. The other thing to remember too is you need to assess your product's performance over time and review that, and also look out for the safety recalls. There's been a number of battery recalls of late. I think one was the LG solar storage battery you stick on the side of your house. That was one example. This element relates to tenders, contracts, contractor management, right? Again, we recognise that contractors are an important element of how operations are delivered in our institutions. A lot of key and core functions are contracted out. So the message we send, effective contractor management begins at the pre-tender stage. So what we've done is we've put together a series of key questions and considerations for tenders, contracts, and contractor management, right? So example, contract clauses, performance KPIs for contractor management, right? And I think the really important thing for people to understand here is that safe battery management must be traceable through both contractor actions but also institutional oversight. So you need to have the mechanisms to make sure that your contractors are doing the right thing from cradle to grave. And lastly, safe disposal. So we talk about cradle to grave, we've talked about procurement, now we're going to talk about disposal. And this is becoming a growing public safety concern in Australia. Be mindful that we all have a duty of care to manage the risks associated with battery disposal. So, just think about how your institution does that. Is it a fragmented approach? Does somebody manage it? It needs to be thought about because, out of sight, out of mind's fine, but the bloke driving the garbage truck, his truck basically catches fire. You don't want to put them at risk. So we need to be responsible with this stuff. There are various battery recycling programs and initiatives across the country. Each of the states and territories have environmental protection agencies that also manage programs and have regulations to address battery recycling. And, you think this really doesn't happen a lot? Well, read some of the stats in the guidance document. And Glenn, I think you've got a quick story for us on this one in relation to Canberra, don't you?
Yeah, we do. We've all seen the fire trucks that dump their load on the streets that are burning, but Canberra was lucky enough or unlucky enough to have a truck make it all the way to the facility, and the fire didn't start until it was compacted in there. So Canberra lost its recycling facility a number of years ago, and it took a couple of years to rebuild and bring a new facility back to life for us. So all of our material was trucked up to Sydney for a number of years, which obviously creates other cost implications, environmental impacts as well. So good battery management, good disposal processes will have a much broader risk mitigation.
Yeah, so that's just an example of the degree of business interruption that can occur. So in the document, there's disposal flow charts. There's a lot of information about how you, should consider disposing of batteries. You know, the fact that, you know, once you get a certain quantity together, it actually becomes a dangerous good, right? So then various other laws take effect and obligations take effect. So anyway, I think, look, that's pretty much us from all from us. I don't know. In New South Wales, there was a once upon a time, many years ago, there was a hardware franchise called Hudson's, and their big advertising, strategy was pretty simple, and it was, where do you get it? Hudson's with an H. Well, as far as this guidance document is concerned, where do you get it? You get it from Uni Mutual with a U, just for you. And also, TEFMA. It'll be on the TEFMA website in the resources section as well. So if you're a Uni Mutual, a member of Uni Mutual, go to our website. If you're a TEFMA member, go to the TEFMA website, and that's where you'll get it. I just want to extend my thanks to the Working Party whilst I have the opportunity. So all those who participated, and to TEFMA for supporting us on this important collaboration initiative. So thanks, everyone.